In this video, we're going to learn the belt drive, which are very commonly used for transmitting the power from one shaft to the another shaft if the distance is very large. So we have a classification of a mechanical power transmission system. Normally the mechanical power transmission system we can classify as a flexible power transmission system or a non-flexible power transmission system. Flexible power transmission system is normally used if the distance is very large between the two shafts, and for compact distance we are using the non-flexible power transmission system like gear drive, which consists of the spur gear, helical gear, bevel gear, worm gear. Whereas the flexible power transmission system consists of either a belt drive or a chain drive or a rope drive. Belt drive is further we're going to study as a flat belt and V belt. Chain drive is of two types. One is a bush and the roller chain type. Second one is a silent chain type. The rope drive is either a fiber rope is used or the wire rope is used. In the gear drive, it is guaranteed that we'll get the positive drive. That is, there is no slippage between the driver and the driven, and in this case the velocity ratio is given as N2 by N1 and is almost a constant value in the case of the power transmission if we are using the gear drives. Whereas in the case of flexible power transmission system, particularly in the case of belt and rope drive, the velocity ratio is given as N2 by N1, and since due to the slippage this value is not constant value. So the belt drive and the chain drive can be used for transmission of mechanical power between the two rotating shafts. Belt drives are often cheaper than the equivalent as compared to the gear and useful for transmitting the power between them. The shafts are widely separated or non-parallel drives. Chain drives are usually more compact than the equivalent belt drive and can be used in an oily environment where the equivalent belt would be prone to slip. In this video, we'll mainly focus on the belt drive, and a belt drive is a loop of flexible materials used to link two or more rotating shafts mechanically. Most of them are parallel, but that is not compulsory. The belts may be used as a source of motion to transmit the power efficiently to track the relative moments. The belts are looped over the pulley and may have a twist between the pulley, and the shaft need not to be parallel. In the two pulley system, the belt can either drive the pulley normally in one direction if it is the open belt, and the belt may be crossed so that the direction of the driven shaft is reversed in the opposite direction. You will find a wide application of the belt, that is the conveyor belt is one of the application where the belt is adapted to carry a load continuously between the 2 points. So normally the belt drive, chain drive and the rope drive are used where the distance between the shaft is large, and for small distance the gears are preferred. The belt drive, chain drive and the rope drives are the flexible type of connector, that is they are bent easily. The flexibility of the belt and the rope is due to the property of their material, whereas the chains have a number of small rigid elements having relative motion between the two elements. In the case of belt drive and the rope drive, they transmit the power due to the friction between them and the pulley. If the power transmitted exceeds the force of friction, the belt or the rope slip over the pulley. In the case of the belt drive and the rope drive are strained during the motion as tensions are developed in between them. Owing to the slipping and the straining action, the belts and rope are not positive type of drive. That is, their velocity ratio is not constant. On the other hand, chains and gear, they have constant velocity ratio. So in this case also, chain drive we have velocity ratio N2 by N1 is always a constant value, whereas VR is not constant value in the case of belt drive and in the case of rope drive. You will find the wide applications of the belt drive. The belt drives are used in various places like A belt drive is used to power transfer drive to rotor on the rotor spinning machine. The belt drive is used as a conveyor drive to drafting rollers and other rolling element on a single delivery drawing machine. Drives to opening rollers, friction drums and take off the rollers on friction spinning machines. Main drive on the draw texturing machine. The belt drive is also used in the mill industry and is drive to creel rolls of a very high speed drawing machine. So there are vast area in which we are using the belt drive. Advantages of the belt drive include it's a low cost and it has a very high drive efficiency of 95 to 98%. It also requires a low maintenance cost. Belt drive does not require a parallel shaft. They can come with the overload and the jam protection. The speed difference can be obtained by using a step or the tapered pulleys. Belt drives are the most economical option when large distance of power transmit between the shaft. Dump out noise and vibration. Load fluctuations are shock absorbed, increasing the machinery life. Clutch action can be activated by releasing the belt tension. At the same time, there are the certain disadvantages of the belt drive. The belt drive are not suitable for the small distance. If you are having a small distance, then you have to use the gears. There is a loss of performance due to the high levels of the slip and the creep. Constant velocity ratio cannot achieve between the drive and the driven pulley. That is the main disadvantage of the belt drive. Secondly, it produces the high noise and it has a low mechanical efficiency. If we classify the types of the belt, then there are total 7 different types of belt drive that can be found, and those are: the first one is the open belt drive, in which the two pulleys are connected by single belt. Then we have a close or the cross belt drive. As the name suggested, we have cross the belt. Then we have fast and loose cone pulley. This type of belt drive, that is a fast and loose cone pulley, is used when the driven or the machine shaft is to be started or stopped whenever desired without interfering the driving shaft. The fourth one is a step cone pulley. A step or cone pulley drive is used to change the speed of a driven shaft while the main or the driving shaft moves at a constant speed. This is accomplished by shifting the belt from one part of the step to the another part. The fifth one is a jockey pulley drive. In an open belt arrangement, if the center distance is small or if the driven pulley is too small, the arc of the belt contact with the driven pulley will be very small, which reduces the tension. Because in this case we have tension T1, which one is the maximum tension divided by the minimum tension, is given as e to the power mu theta, where theta is the contact angle, T1 is the maximum tension, T2 is the minimum tension. This relation will prove, and hence if the distance is small, angle of contact will be small, and therefore we have a less power transmission. In that case, the idler pulleys are used on the slack side of the belt to increase the tension and to increase the arc of contact, and thus stress resulting in an increase in the power transmission. The power is transmitted is given as the maximum tension T1 minus minimum tension T2 multiplied by radius r. That will be the torque multiplied by 2 pi n divided by 60. So it entirely depends what is the value of T1. Higher the value of T1, higher will be the power transmission. The sixth one is a quarter turn belt drive. This type of drive are also known as the right angle belt drives. It is used with the shafts arranged at the right angles and rotating in a certain direction. And the seventh one is a compound belt drive. A compound belt drive is used when the power is passed from one shaft to another through multiple shafts. So there is a continuous arrangement of the open belt and the pulleys are mounted in parallel on some common shafts. We will discuss here one by one. The first one is the open belt drive. In the case of the open belt drive, we have seen here one pulley and we have second pulley, and this arrangement shows here the belt is wrapped around the pulley. This one is called as the open belt drive. So open belt drive is used when the driven pulley is desired to rotate in the same direction as the driving pulley. In this case, this pulley will rotate in a clockwise direction. In that case, the driven pulley will also rotate in the same direction, that is a clockwise direction. Generally, the center distance for an open belt drive is approximately equal to 14 meters or 14 to 16 meters. If the center distance is too large, the belt will whips, that is vibrate in a direction perpendicular to the direction of motion. And for very short distance, the belt slip increases. Both these phenomena limit the use of belt for power transmission. That is, the distance will increase more than 14 to 16, then the vibration is a problem. And if the distance is less than 14 meter, then we have the slip problem, and therefore we have limitation of using the open belt drive. So while transmitting the power, one side of the belt is more tightened, known as the tight side, than the other side, which is known as the slack side. So suppose T1 represent here the tension on the tight side and T2 represent the tension on the slack side, then their ratio is given as T1 by T2 is equal to e to the power mu theta. This value of theta is basically from the point of contact of pulley, that is this angle sustained will be called as here the angle theta, which one is also called as the angle of wrap. Naturally, we desire here the higher value of theta. If we have a higher value of theta, we have higher value of T1 and we have more power is transmitted. So consider here the pulley are rotating in a clockwise direction. So we have a clockwise rotation of a driver pulley as well as a driven pulley. We find here the bottom side is a tight. So this one is representing the tension T1. That is the tension on the tight side. And the top of the belt is slack. So this one is representing the tension T2 on the slack side. So in case of horizontal drive, it is always desired that the tight side is at the bottom of the lower side of the two pulley. This is because the sag of the belt will be more on the upper side than the lower side. This slightly increase the angles of wrap of the belt on the two pulley. So because of this, we will find here the angle of contact will increase. So this will be the angle of contact, that equal to theta. Theta you have to always select for the minimum value out of 2. In case the tight side is at the upper side, the sag will be greater at the lower side, that is the slack side. In that case, the point of contact will start from this point up to this point. Clearly here we observed here the two different value of theta. So this time I will say the value of theta is equal to theta 2, and here we have theta is equal to theta 1. So if the slack is on the above side, then the theta 1 value is greater as compared to theta 2. Naturally, if the theta 1 is more, T1 is more, that is desired. So when we have the slack side on the top side, then we have value of angle of wrap theta 1, and when the slack side is on the bottom, in that case the value of theta 2 will be less than the value of theta 1. So this arrangement is always preferred, that is the slack is always preferred on the top side of the pulley. Because if the value of theta 1 will be larger, the value of T1 will be larger. So as theta increases, the value of T1 also increases, and since the T1 is increases, we have power is given as T1 minus T2. This one is a tension which has a unit of Newton, multiplied by radius r multiplied by 2 pi n divided by 60. Actually, if the tension is higher, the power transmitted will be also higher, and therefore the slack side on the top is always a preferred as compared to the slack side on the bottom. So in the case of the horizontal drive, it is always desired that the tight side will be at the bottom side of the pulley and the slack side will be on the top of the pulley. The second type of arrangement used is a cross belt drive arrangement. In the cross belt drive, it is adopted when the driven pulley is rotated in the opposite direction to that of a driving pulley. So here this one is representing the driver pulley will rotate in a clockwise sense. In that case, the driven pulley will rotate in a anti-clockwise sense. So when you desire that the two shafts on which the pulleys are mounted should rotate in the opposite direction, then you can use the cross belt drive. If you observe the cross belt here, in that case the cross belt will cross at certain point. So at a point where the belt crosses, it rub against each other and there will be excessive wear and tear will take place. To avoid the wear and tear, you have to maintain a distance between the two shafts, that is the center distance C should be greater than equal to 20 times of B, where B represents the width of the belt, and secondly the speed of the belt must be less than equal to 15 meter per second. In that case we can avoid the wear and tear in the case of cross belt. One observation you have done in the case of the cross belt drive is the angle of contact has been increased as compared to the angle of contact in the case of open belt. Now since the angle of wrap is more, that is the value of theta is more, T1 value will increase. And if the value of T1 will increase, naturally the power will also increase. The third arrangement used is the fast and the loose cone pulley. So we have a driver shaft and a driven shaft. On a driver shaft only one pulley is mounted whose width is more as compared to the loose and the fast pulley. So this type of belt drive is used when the driven or machine shaft is to be started or stopped whenever desired without interfering with the driving shaft. A pulley which is keyed to the machine shaft is called as the fast pulley. So this one is the machine shaft and its keyed pulley is called as the fast pulley. Will run at the same speed as that of a machine shaft because the belt is passed over the driver pulley to the fast pulley. A loose pulley runs freely over the machine shaft. So this pulley is called as the loose pulley which runs freely on the machine shaft and is incapable of transmitting any power. When a driven shaft is required to be stopped, so when the driven shaft, that is the machine shaft, is required to stop, the belt is pushed onto the loose pulley by means of a sliding bar having the belt fork. In this fashion, the fast and the loose cone pulley will work. So the difference between the fast pulley and the loose pulley is that the fast pulley is keyed to the machine shaft, whereas no key connection is used between the loose pulley and the machine shaft. Since there is no connection between the loose pulley and the machine shaft, it is incapable of power transmission. And since the fast pulley is keyed to the machine shaft, it is capable of power transmission. Hence, whenever the driven or the machine shaft is to be started or stopped, we can use the fast and the loose pulley. The fourth type is the step cone pulley drive. So we have a driver pulley in which the 3 steps are provided. Similarly, in the driven pulley also we have 3 steps are provided. So this arrangement is normally used to change the speed of a driven shaft. We can attain here 3 speed, that is N1, N2, N3 depending upon the number of steps that is provided on the driven pulley. The driver pulley speed is remain constant, so value of rotational speed N is remain constant for the driver pulley. At the present case, the larger diameter of the driver pulley is engaged with the smaller diameter of a smaller pulley. Since the linear speed is remain constant here, neglecting the speed, we have V1, that is this one we called as pulley number 1 and we'll call this as pulley number 2. So we have V1 is equal to pi into D1 into N divided by 60. As far as V2 is considered, we have V2 is equal to pi into d2 into n2 divided by 60. Since here the both has the same linear velocity, so this time we have v1 is same as equal to v2. Pi divided by 60, pi divided by 60 will get cancelled. We have d1 multiplied by n is same as equal to d2 multiplied by n2. So we get the value of n2 is equal to n times d1 divided by d2. But if you engage the step cone 3 with step cone 4, then the speed will change. In that case, you can find out the value of n4. Now the rotational speed of the 1, 3 and 5 is remain same. That is the value of n1 is same as equal to n3 is same as equal to n5. n4 will be same as equal to n multiplied by the diameter of the pulley 3 d3 divided by the diameter of the pulley 4. So we are getting here the variable speed as the belt will shift from 1 to 3 and 3 to 5. So a step cone pulley is an integral casting consisting of 3 or different numbers of different sizes of pulley adjacent to each other. A set of driven cone pulleys are placed upside down on the drive shaft. An endless belt will be wrapped around the pair of the pulley. By shifting the belt from one pair of the pulley to another pair, the speed of the driven shaft can be varied. The diameters of pulleys driving and operated is such that the same belt will operate when the transferred over the pairs of different pulley. So diameters are adjusted such that the length of belt is remain same. So whether we have 1 and 2 engages, the belt length equal to L, or 3 and 4 engages, that time also we have length is equal to L. At a time only one belt is shown. This is discussion is for same length of belt. And when the 5th and 6th will engage, we have a same length. So same length can be used here for various engagement, 1 with 2, 3 with 4 and 5 with 6. Length will not change. So you have to select the diameter of the pulley of a driving and the driven such that the same belt will operate when transferred over the pair of pulleys. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.